Explanation on what parameters and how assay conditions affect enzymatic activity. These are the topics that we're going to be covering today. What's an enzyme? Enzymes are composed by different structures. Primary, polymers of amino acids that are joined together by a peptide bond, in other words, a polypeptide. Secondary, a localized polypeptide structures such as alpha helices or beta sheets. They are held together by hydrogen bonds in the alpha carbon and N-terminal. Tertiary structure, also called subunits, are three-dimensional folds of polypeptide chains that are held together by hydrophobic interactions, hydrogen bonding, disulfide bridge, ionic bonding, as well as van der Waals forces. Quaternary are an arrangement of series units that become a mature enzyme with an active site. They are held by non-covalent bonds between complementary surface hydrophobic and hydrophilic regions of the polypeptide subunits. Utility: enzymes are catalyzers of specific reactions such as redox, meaning that they reduce the necessary energy and time for it to happen. This is because enzymes have an active site where the substrate binds and undergoes said reaction. The area of chemistry that studies enzyme activity is enzymatic kinetics. How can they be modeled? Using Michaelis mental kinetics and using Line-Weaverbrook plots. V0 stands for the initial velocity, S for the substrate concentration, Vmax for the maximum velocity, Km for the substrate concentration at half Vmax. What affects enzymatic activity? First of all, temperature. Enzymes have an optimal temperature. If we surpass that temperature, enzymes can become denatured. As well as pH, they have an optimum pH. pH affects the amino acids charges, which affect the secondary structures in the hydrogen bonds. Concentration of enzyme and substrate. Enzymes can be saturated with far more substrate than it can handle. Presence of inhibitors and cofactors. Inhibitors essentially prevent the enzyme from acting correctly, and cofactors activate said enzymes. By technological opportunities, pharma, right now, enzymes can be used to treat chronic diseases such as Gaucher's, where gene mutation renders the body disabled to complete necessary tasks. Industry. Enzymes also have an area of application in the food industry, such as lactase in dairy products, and commercial industry by doing solid fermentation with cellulase to degrade cell walls and harvest natural wax in plants, such as the Candelilla plant. Opportunity. In my point of view, enzymes can be applied to almost every aspect in our life. Nevertheless, it is still inaccessible due to high operational costs. It should be a priority to research more cost-effective ways to benefit from enzymes. These are the references.